Hello, my name is Haoyu Long from Seoul Yatsen University. The topic of my presentation is Global Circulation Dynamics and its Determinants of Dengue virus, a network evolution and model study from 1990 to 2019. Dengue is the vector-borne infectious disease that caused by dengue virus. It is estimated that there are about 390 million infections and 10,000 deaths per year. Dengue is one of the 10 threats to global health. At present, there is no effective anti-dengue virus drug, and no dengue vaccine is in widespread use. Dengue virus is a single positive stranded RNA virus which can be characterized into 4 serotypes, including dengue virus 1, 2, 3, and 4. With the climate change and the increasing human movement around the world, dengue is expanding from tropical and subtropical zones to a global scale. However, there is less systematic research on dengue global circulation. A study on dengue transmission in Asia has found that Thailand and India may play as the sources of dengue in Asia, but their roles in dengue global circulation are unclear. The scale of genetic evolution of RNA viruses often matches that of their transmission and epidemics, providing a way to study the circulation of virus elaborately. Furthermore, network-based methods have been developed to study the transmission of infectious viruses efficiently, offering new ways to explore global circulation of dengue based on genetic sequences. Therefore, in this study, we explore global circulation of dengue based on genetic information through a network-based approach. 4 circulation indicators were defined, including local intensity, betweenness centrality, tip frequency, and persistence time. Based on the indicators, 3 circulation routes, including source, hub, and destination, were further classified. In addition, spatial and temporal change of the circulation routes and the persistence time were explored in 3 decades between 1990 and 2019. Furthermore, associated factors were identified to provide targeted information for precise intervention of dengue control. 7 categories of data were collected and processed. To match the scale of dengue epidemics in different regions, the number of dengue cases were taken into account during sequence sampling, simulating the real situation of dengue epidemic to some extent. The network was generated as the procedure of previous study, and this method has been validated the robustness and accuracy in detail in the previous study. Local intensity was calculated as the degree of the nodes of the same region and weighted by the weights of the edges. As to betweenness centrality, it is the measure of how often a node is in the shortest path between 2 other nodes in the network. The definition of tip frequency for a region is the frequency of tip nodes, indicating the strain might start circulating and disappearing in this region. As to persistence time, firstly, random walks were performed to find the circulation routes of dengue virus. The routes from the same region within the period of the stage were identified. Then the span of year between the starting to the final year of the route was calculated. The median of the distribution for the span of year were obtained as the persistence time of dengue virus for a specific region. It shows that Thailand, Indonesia, and Vietnam in Asia, and Venezuela and Colombia in the Americas were identified as sources for all 4 serotypes in different decades. Besides of that, it is interesting to find that the destinations are mostly in island regions such as Madagascar, Fiji, Jamaica, Barbados, and so on. In addition, over the decades, the number of regions with different circulation routes and persistence of dengue virus 1 increased significantly. Moreover, the key regions with circulation routes for dengue were mainly located in the latitude of 10 to 20 with no significant change. And the median persistence time is about 1 to 3 years for the four serotypes, and there is no statistically significant difference across decades. Moreover, climate, population, socioeconomic, and forest factors were found to be significantly correlated to circulation indicators of dengue to different extents. Furthermore, three machine learning models were constructed and the SHARP framework was developed and applied to interpret contribution of variance factors based on machine learning models. The five categories of factors were all involved in the important determinants to the circulation roles and persistence of dengue. What's more, climate is often the important determinant to the circulation roles, and ARI is to that of persistence of dengue. In summary, Thailand, Indonesia, and Vietnam in Asia, and Venezuela and Colombia in the Americas were identified as sources for all four serotypes in different decades, and destinations were observed mostly in island regions. And over the decades, the number of regions with different circulation roles and persistence of dengue virus 1 increased significantly. However, no difference for median persistence time were found across decades, as well as the mean latitude of regions with different circulation roles. Moreover, climate, airline population, socioeconomic, and forest factors were important determinants of the circulation roles and persistence of dengue. Thanks, that's all my presentation.